Alright, so we have a photoelectric effect problem. Let's start by finding out the energy of the incident photon, which is calculated with hc over lambda. Okay, so we're going to write down our constants here. Our wavelength here is 280 nanometers. So that works out to be, well, I'll write it down here. That works out to be 7.1 times 10 to the minus 19 joules. Now I'm going to convert that into EV. Here's my conversion factor. Right? So that's 4.44 EV. Now our formula for photoelectric effect is that the maximum kinetic energy of the incident, or of the escaping electrons, is equal to the energy of the incident photon, which is the hc over lambda that we just calculated, minus the work function. So if I want to find the work function, phi, that's the energy of the incident photons minus the kinetic energy of the escaping electrons. These two things were given, right? The energy of the incident photons is 4.44 eV, and we're told that the maximum kinetic energy of the ejected photoelectrons is 1.72. Therefore, the work function is 2.72 EV. Alright, so there's part A. Now part B asks, what's the cutoff wavelength? Well, cutoff wavelength is gotten when the maximum kinetic energy of the escaping electrons is 0. That is, the electrons escape, but just barely. They've got absolutely no extra energy to spare when they escape. And so the energy of the incident photons is just equal to the work function. Alright, so let's see, that's saying hc over lambda is equal to the work function. So if I want to find the cutoff wavelength, I can say that lambda is equal to hc over phi. Okay, so here we go again. I'm going to write down these constants. Alright, now I divide by the work function, but I need that work function in joules, right? So it's 2.72 EV, but then I've got to multiply that. Right, this is an EV. I got to multiply that by 1.6 times 10 to the minus 19 joules over 1 EV. Okay? So if I multiply all that out, I get 457 nanometers. That's it.